Hilchos Kiddush Hachodesh Perek Arba'a Asar. The laws of sanctifying the new month, chapter 14. Let's not lose track of the ultimate goal of these chapters. We're trying to figure out if on the night following the Molad, the night after the moon and the sun come back into alignment, will we be able to see the new moon? And mathematically the question is, will the moon have gotten far enough from the sun to the east that after the sun sets and the moon is the only star that remains in the sky, will there be enough time before the moon sets too to be able to sight the new crescent of the moon? In order to answer that question, we need to figure out where is the sun on its orbit, where is the moon on its orbit, what's the distance between the two, and then we'll be able to have the answer to the question if the moon got far enough from the sun. Now, we've seen, when it came to the sun, that Rambam spent 2 chapters to explain to us that there is an average position and a true position. Average position means where is the sun on its own orbit, what we call on the orange circle. The sun is traveling around the earth at a steady rate of about 1 degree per day. And based on that, you can identify, if you just use this circle, you can identify the average position of the sun. Tell me, this is 0 degrees, which degree is the sun on? When it came to determining the true position of the sun, true position means where is the sun going to be viewed by an observer on earth? Once you go to the true position, we learned that you have to make some adjustments. First of all, because even if the sun's orbit were stationary, like we see in these 2 lines, if you're at the center of the sun's orbit, you're going to see 90 degrees. If you're on Earth, you're going to see a different degree. It's going to be behind. But more so because the entire orbit of the sun is off-center. So we have the gova, that's the apogee, the point that's furthest away from Earth. That point is also moving. So that's going to dictate also the adjustments to be made for the sun in order to be sighted in the true position. So while it was a bit complicated, it was fairly simple, if I can say so. In just 2 chapters, we were able to ascertain the true position of the sun. When it comes to the moon, it's going to be much more complex with many more steps. Because as we'll see, and the Rambam says it himself later in these laws, Hayareach al kalkalot gdolot yesh b'mahalacho. The moon has many crookednesses in the way that it walks, in the way that it moves. In other words, when the astronomers observed from their point on Earth the path of the moon, there was so much complexity. It looked like it was making not just circles, but ovals and weird types of circles. One day seemed to be completely unpredictable from the next day. So they had to come up with a whole methodology to explain how the moon is actually orbiting the Earth. With today's sciences, we have different ways of describing it. We don't describe it in circles, we describe it in ovals. There's different ways to maneuver the astronomical science that we have today. But in the Rambam's time, they only spoke about circles. Everything had to be a circle. So if you saw the moon moving in a way which didn't match the circle, you know what you did? You just invented another circle. And that's the way of explaining.
What do you mean invented another circle?
What do I mean another circle? So let me show you how it looks, and then we're going to go into the chapter. See, if the moon were just like the sun, so we would have this. We would have the circle, the orbit of the moon around the Earth, and beautiful, we just track how the moon is going around the orbit, around the Earth. The problem is that it's not. If you're an astronomer, you look out to the sky, the moon is not making an even circle. So what did they say, the scientists of the time? And the Rambam adopts this viewpoint, that actually there's 2 cycles happening at the same time. One is, yes, the moon is moving around the Earth, but the moon is also circling in a mini circle. This is called the epicycle in science. Can you see that? There's a little circle where the moon is actually journeying around in this little circle. So while that entire little circle moves along the orbit, the moon is also it's also spinning within that little epicycle. And this explains why the moon sometimes looks forward, or sometimes it looks backward, sometimes it looks back, sometimes it looks forward, because there's an entire little cycle that's taking place.
And it's going from west to east, right?
And that's another point, is that it's going backwards. While the moon, the whole circle is going around the orbit counterclockwise, eastward, from west to east, this one is going from east to west. This one is going clockwise.
East to west.
So now, forget the true position of the moon. Forget the position of the moon from the point of an observer on Earth. Just to establish the average position of the moon. And average again means relative to its own orbit. Just to establish the average position of the moon, we're going to have to already make adjustments. We're going to have to figure out where is the middle point of this circle along the larger orbit of the moon, and where is the small circle, or where is the moon on the small circle. So to demonstrate it for a second, this would be if the moon is at the very back edge of the small circle. So here you can see at the center point of the moon's orbit is at about 15 degrees, right? Because this is 0 degrees, that's 30, so it's at about 15 degrees. And the moon, because it's in the back of the circle, it's pretty much aligned with that. So we would actually see it at the same degree over here, about 15 degrees. But watch what happens in this case. What if the moon, on its little cycle, is on the right side? So while the middle of the orbit, yes, is at 15 degrees, but because the moon is spinning on its little cycle, when you look out at it, you're going to see it at about 7 degrees. Same thing would be on the other side. Let's say the moon was on the other side of the epicycle. Again, the middle of the cycle is at about 15 degrees, but because the moon is spinning on its own little circle, when you look out, you might see it at 30 degrees. This is all, by the way, I'm just saying it again, this is all for the average position of the moon. We're going to do much more corrections, many more corrections to reach the true position of the moon. Right now we're trying to establish where the moon is.
I understand.
So the Rambam is telling us you have to know two things. You have to know where is the center of the moon's little orbit, because that center moves along the larger orbit. But that's not enough. If I knew the center was here, so I could say, oh, the moon is at 15 degrees. No, it's not, because the moon is making a little circle on its epicycle, and actually it's over here today, which means that it would be seen at 30 degrees. So it's just an adjustment that you have to make. I'm just trying to demonstrate to you that there's two motions of the moon happening simultaneously. The entire little circle is moving along the orbit, and then the moon is moving along that epicycle. So if you want to know where the moon is, you're going to have to do two things. First, figure out where is the center of the little circle. This is called the Emtza Hayareach in today's chapter, the average position of the totality of the moon. And then you have to figure out where is the moon on the little cycle. That's called Emtza HaMaslul, the average position of the path that the moon is taking around its epicycle. And this is, again, before any other adjustments. Okay, let's see the Rambam inside. Halacha Aleph, Hayareach Shnei Mahalochim Emtzo'im Yesh Lo. The moon has two average rates of progress. Again, before the true position, just the average establishment, you're going to have to deal with two simultaneous motions. Hayareach Atzmai Mesabev Begalgal Koton She'eino Makif Ha'So'ilam Kulei. The moon itself is spinning around in a little sphere, which doesn't surround the world. That's the little epicycle there, the blue circle. The average progress that it makes in that small epicycle, Nikra, is called Emtza HaMaslul, the average position of the path that the moon is taking throughout the epicycle. That entire small circle is itself turning on a larger sphere, Hamakif Ha'So'ilam, which does indeed surround the world. Shel galgal katan, be'oisei hagalgal hagadol hamakif haso'ilam, or maybe that base is extra. Umahalach emtzoi zeh, this average progress, shel galgal katan, be'oisei hagalgal hagadol hamakif haso'ilam, which the small orbit makes within the large orbit which surrounds the world, hu hanikra emtza hayareach, is called the average position of the moon, because it's the moon in its totality, the entire circle of the moon. And like the Rambam did in chapter 12 for the sun, he gives us all the rates of progress for the moon. Mahalach emtza hayareach b'yom echad. How far does the entire moon's orbit, and therefore the middle of this moon's orbit, how far does that move along the orbit of the moon every day, one day? 13 degrees, 10 minutes, 35 seconds. It's quite a lot. With the sun, it only moved 1 degree per day. The moon is making a progress of 13 degrees per day along its orbit.
And that's everything together.
That's the entire little circle together moving along the big circle.
13 out of 360.
13 out of 360. Beis nimsa mahaloche ba'asara yamim, turns out that the progress that it makes in 10 days would be me'av ve'achas u'shleishim mailes v'chamisha v'arbaim chalakim v'chamishim shniyos simanam kuf lamed aleph mem hey nun, a very significant amount, just 10 days. 131 degrees, 45 minutes, 50 seconds. V'nimsa she'edis mahaloche b'me'ah yayim, the remainder of its progress in 100 days. Of course, the word remainder is used because in 30 days it makes a full revolution, and all we care about is the number less than 360. So in 100 days, The remainder of its progress will be Masayim v'sheva o shleishim mailes, o shmeino o shleishim chalakim, v'shalish v'esrim shniyos, simanam reish lamed zayin lamed ches chav gimel, 237 degrees, 38 minutes and 23 seconds. V'nimtzes she'edis mahalache be'elef yayim, in 1,000 days, it makes countless revolutions around the earth. But what is the remainder? What is the net progress that it makes? Masayim v'sheish esrei mailes, o shleishim v'esrim chalakim, v'chamishim shniyos, simanam reish yud vav chav gimel nun, 216 degrees, 23 minutes and 50 seconds. In 10,000 days, how much progress does the moon make? Net progress. Just 3 degrees, 58 minutes and 20 seconds. Again, it goes around the world many, many, many times, but in the end, the bottom line progress is just 3 degrees. The important factors, the important numbers, what turns out is, in just 29 days, the remainder of its walk, of its progress is Shtayim ve'esrim mailos v'shisha chalakim v'sheish v'chamishim shniyos simanam chav beis vav nun vav. 22 degrees, 6 minutes, 56 seconds. Because even in 29 days, which we call a month just means from the time it's with the moon, it's with the sun, to the time it catches up to the sun. But it makes a full revolution around the earth plus more. A full revolution around the earth plus another couple of degrees to catch up to the sun, which also has been making progress. The Nimtza She'edis Mahalache B'Shana Sedura, and in a regular year of 354 days, how much progress does the moon make? Shleish Me'ez v'arba v'arba'im mailos v'shisha v'esrim chalakim v'shalish v'arba'im shniyos siman lahem shin mem dalid chavav mem gimel, 344 degrees, 26 minutes, 43 seconds. V'alderech zu, and following this way, once you have the progress for a day, of course, tichper l'chal minyan yamim meshanim shetirtza, you can go and multiply for whatever number of days or years you would like. That's all as it refers to the entirety of the circle. Now let's talk about the moon's progress on the epicycle itself. How much progress does the moon make on its own little course? On the epicycle in one day, very close number, by the way, 13 degrees also, 3 minutes and 54 seconds. But like we said before, it's moving the opposite direction. The moon's orbit is moving around this way, counterclockwise. The moon on its epicycle is moving around clockwise. So it comes out that its progress in 10 days, again along the little circle, will be exactly 130 degrees and 39 minutes. The net progress in 100 days is Masayim b'sheish v'esrim mailos v'tisha v'esrim chalakim v'shalish v'chamishim shniyos simanam reish chavav chav tes nun gimel, 226 degrees, 29 minutes, 53 seconds. In 1,000 days, the net progress will be 104 degrees, 58 minutes, and 50 seconds. In 10,000 days, the net progress that it makes will be 329 degrees, 48 minutes, 20 seconds. The important number is in 29 days, every month around, the progress that it makes is 18 degrees, 53 minutes, 4 seconds. And the regular year, the net progress in a regular lunar year, 354 days, is again a round number, 305 degrees and 13 minutes exactly. And as the Rambam did with the sun, he does it again with the moon. He gives us the position and the starting point. The placement of the average position of the moon, which means again, where was the entirety of the epicycle, the entirety of the circle, was where? At the beginning of Thursday, 3rd of Nisan, 1178, 4938, which is the starting point for these calculations, where was the center of the orbit? The Mazal Sher, the Arba, again, the Mazal Sher, Maila Achas, the Arba Asr Chalakim, Arbaim, V'shalish Niyos, Simanam Aleph, Yudalid Mem Gimel. It was at 1 degree, 14 minutes, and 43 seconds, but not 1 degree from 0, 1 degree of Mazal Shor, so 31 degrees. So I should show you this picture. Yeah, this will just represent it again. Now I'm showing you as if the moon itself is on the orbit. It's not. You know that it's on an epicycle. But this was where the Emtza HaYareach was on the night of the Iker. It was right here. This would be 31 degrees because it's finished the entire Teleh. It's 1 Mazal into the Mazal of Shor, the Mazal of Taurus. The Emtza HaMaslul Haya Be'ikar Zeh. And where was the moon on the little path? On the epicycle at the starting point, it was at Arba Ushmainim Mailos, Ushmaina Ve'esrim Chalakim, Ushtayim Varbaim Shniyos, Simanam Peidalid Chavches Membeis, 84 degrees, 28 minutes, 42 seconds. But this time, like we said, the 84 degrees means the 84 degrees going from right to left, clockwise. So it would be just around there, because 90 degrees would be the quarter of the circle, and 84 is about there, just about. Once you know the progress of the moon's general orbit and the average position at time of the starting point from which you can add to, so of course you can figure out where the moon will be at any time that you want, as you did with the average placement of the sun. And now the Rambam returns to something which he mentioned 2 days ago. Once you achieve and you figure out where is the position of the moon's orbit at the beginning of a given night, because again, if we say the progress per day, it brings you to 6 p.m. on any day. You must figure out, in simple English it means, you must figure out what season of the year it is. You must look at the sun and see which constellation it is. In other words, you have to figure out which time of year are we in. Because the time of year depends on where the sun is on its travel. And where the sun is on its travel will dictate when sunset is. So even if you have the position of the moon for 6 p.m., 6 p.m. isn't always sunset. 6 p.m. is sunset in the spring and in the autumn. But it's not sunset in the winter. Sunset is earlier. In the summer, it's later. And for the moon, that's very significant. Because if the moon travels 13 degrees per day, that means every hour it's making progress about half a degree. So it's very, you got to know how much.
In the middle of the day.
Yeah. So you have to know where is the moon going to be at sunset of my day. And how do I know where the moon will be at sunset of my day? So the Rambam says, check where the sun is. And he gives you a very approximate adjustment. And that's fine. Because the approximate adjustment is all we need to figure out where the moon will be at Sha'as Hariyah, at the time of the sighting, which is sunset of that particular day. So the Rambam says, Halacha Hey, if the sun was between halfway through Pisces and halfway through Aries, in other words, it's literally springtime, half a month before, half a month after, leave the position of the moon as is, because what you've got for 6 p.m. is probably sunset. Will be around 6 p.m. in those days. But if the sun is anywhere between halfway through Aries till the beginning of Gemini, this is like the month of Nisan, Iyar, that time, so the days are getting longer, you need to add to the position of the current orbit of the moon about 15 minutes, a quarter of a degree, because sunset's going to be about 15 minutes later. This is the most extreme time of the year, the northerly time of the year, from Gemini until Leo. This is, we're talking now, Sivan, Tammuz, Av. Should probably say Shloishim over here. Shloishim Chalakim, yeah. You have to add to the middle position of the moon 30, a full half of a degree, 30 minutes, because sunset's going to be about an hour later. Now once it's starting to get to the end of the year, beginning of Tishrei, and here it's again, Chamisha Chalakim, yes? It's a mistake over here. You have to add to the position of the moon, again, just only a quarter of a degree, because sunset is getting earlier. From halfway through Virgo, through halfway through Libra, Tishrei time, leave the position of the moon as is, because again, sunset's roughly about 6 p.m. But now, once you're moving to the winter time, once the sun goes from halfway through Libra to the beginning of Sagittarius, now you have to subtract a quarter of a degree, because sunset's going to be earlier in the day. At the most extreme southerly points, if the sun is from beginning of Sagittarius to the beginning of Aquarius, now you're subtracting a full 30 minutes, a half a degree. Gedi is Capricorn, but here it says Deli. Yeah. V'im tiyeh hashemesh mitchilas mazdal dli ad chatzi mazdal dagim, and now the month of Tevet, Shvat Adar, once it's back to Aquarius, back to halfway through Pisces, tigra me'emtza yareach, only chamisha asur chalakim. All you have to do is subtract just 15 minutes, a quarter of a degree, because sunset's getting a little bit later, closer to 6 p.m. Halacha vav, u'mashe yiyeh emtza ha'emtza. Whatever the average position is, after you add or subtract or leave it as is, depending on what time of year it is, hu emtza hayareach la'achar shkia sachama b'kumay shlish sha'ah b'oisei azman shetoitzi ha'emtza loy. I've given you the number to adjust for after sunset, about a third of an hour, about 20 minutes at the time that you are in, because that's your window of sighting. 20 minutes after sunset, the sun is set sufficiently below the horizon, and if the moon is going to be big enough, you'll be able to see it. That's called the position of the moon for the time of sighting. First, you want to know the progress per day to 6 p.m. Then you adjust for the time of year to know where the moon's going to be at sunset or 20 minutes after sunset, and that will help you with the beginning steps of figuring out whether you can see the moon on this night of sighting.